Welcome. In this video I'm going to show you how you can obtain Cramer V for a goodness of fit test as an effect size measure for a goodness of fit test. I'm using Python version 3.12, I think, 12.7, and in this video I'll be using my stikpetP library to do so, to obtain the measure. You can actually also convert this measure to a Cohen W and then use rules of thumb for Cohen W, or just use Cramer's V rules of thumb. To show you how this can be done, I need some example data, so I'll be loading in Panda, so I can use their read CSV function to load in some data from the General Social Survey from 2012, which I've adjusted a little bit for some example purposes. I actually don't need all of its data, I just need one nominal field. And for this example, I'll be using the marital status, which was actually stored under mar1. So I'll use that as nominal field. To give you a quick impression, their value counts. To be shown, 79 people, for example, indicated that they were separated. Now, this is after you've done some kind of chi-square test. So you first actually need my library, which is available via pip install, and then the full link to my GitHub account and the file over there. Once you've installed it, you can actually use and import it just as any other library, and it only needs as input the chi-square value, the sample size, and the number of categories. Optionally is also to use a Bergsma correction. Now, the library also has a function to do, for example, a Pearson goodness of fit test, but there are other goodness of fit tests. But just as an example, I'll be using the Pearson one. If you're interested, I have separate videos on performing the tests themselves. The results will then actually have the chi-square value, the sample size, and it will have the degrees of freedom, but if you then add one, you actually get the number of categories again. So these are fairly straightforward to obtain once you've done the test. Now Cramer's V is then just using that function, put in the chi-square value, the sample size, and the number of categories, and we have ourselves Cramer's V for goodness of fit. You can use the function th, short for thumb rules, for Cramer V to get some rule of thumb. There are alternatives for this one, so you can do a question mark and then just the function name to see which other options are there. If you like, you can also convert it to a Cohen W value using the esconvert function. And then once we have a Cohen W value, we can use the rules of thumb from Cohen W. The Bergsma correction is just by indicating true at the end, and as you can see, that has a slightly different result now for Cramer's V than we originally had. Alright, and I think that's about it. I hope this video was helpful, and thank you for watching.